Hello, everybody. I think it's my last conference. Yes, I began in 1978. My skill was remote sensing, applied geology, GIS, of course, but the beginning of GIS, and geostatistics. And I would like to present you a plugin in QGis. It's the first plugin in QGis because I have worked since a long time with ArcInfo and the S3 product. Okay. Uh, ah, I have a problem. Yes. So I define what is radioecology, to whom it belongs, the problem, the solution, maybe one solution, and the conclusion and perspective. What is radioecology? Radioecology is the science of radionuclides, dust particle with radioactivity, natural or artificial, and to detect the origin, the transfer, the dispersion, the concentration, and at the end, a dose with an impact and sanitary impact. I belong to a very new company because it was created in January of this year with one side, ISAN, Nuclear Safety Authority, and the other side, the IRSN, Institute of Radio Protection and Nuclear Safety. It's an idea from our president, Emmanuel Macron, and now it's a very good system because we are judge and party. We are about 2,000 people. Symbiose is a platform of simulation used in radioecology in order to simulate the transfer of radionuclides in the environment and assess the associated human and biota. One is asset is to calculate on site specific with the geographical characteristic, with the land use and the population. Calculation are only where the product is. It's very important because what is still done, even in my company, it's, for example, here for Fukushima, we have the commercial limit for leafy vegetable. And of course, the land use is not taking into account. There is leafy vegetable in the sea, in the China Sea, and in the ocean, in the Pacific Ocean. And even on land, on the gray one, on the right, there is 80% of forest. So leafy vegetables are only in the yellow areas. So it's not enormous. It's just a little part of the landscape. So a plugin was created under QGis, and there is a lot of possibility. The possibility first to create and import a grid, and it's possible to have square, hexagon, triangular, and so on and so on. Everything is possible. And then it's possible to model the land use with the characteristic. With the characteristic of the landscape, but the reality of the landscape. The reality is taken into account with satellites, image satellites, or land use coming from local studies. Then it's possible to model the hydrographic network with a digital elevation model or with triangulation. And at the end, it's possible to have a transformation of all the geographic entities into a XML file, because Symbiose use XML. Each step can be performed independently for other applications, and not especially in the context of Symbiose. I have a problem because yes, I return to this slide because I forgot something. You have three nuclear sites, one in Czechia on the left, in the center one in France, and on the right one in United Arab Emirates. So the landscape is not the same. It's important. The first is crops and forest. The second is urban area with about 1 million people. And the third is desert. So calculation will be not the same for any site. I was here. So the first is to have a lot of data of land use, digital elevation, and hydrographic network. It's data coming from the web. And then the geoprocessor try to combine a grid with the land use and transform the hydrographic network into a center line about. And then for Symbiose, it was created XML file. The preparation of the data is very important. For land use, all data is it's possible to work with all data. For geographic network, it's the same with all. The different software we use are a lot. With ArcGIS, of course, because we work with ArcGIS since we have worked since 1985. FME, very interesting for topologic. ERDAS, NV, UTB, and QGis, of course. But QGis is the last one. And pay attention to the semantic integrity. It's very important. For example, forest is not written every time with the same orthograph. Use the good surjective rules in order to have only the classes you would like to have. And the most important one, because now I work from 10 years ago, it's a topology. We have a lot of data, but we have a lot of errors. Overlaps, of course, duplicates, or for hydrographic network dangling nodes. The processor, you see, it's by alphanumeric, of course, but it's between Grass and Saga. It's very beautiful. And why open source? Symbiose is free. It costs a lot of money. It's about 20 years old, but it's free. We have a big experience with S3 since the beginning. And in order to spread SYMBIOSE, I think it's not with ArcGIS or ArcGIS Pro or ArcInfo, it's with QGis. So we try to make this processor in order to spread SYMBIOSE with an open source. The processor in details. So it's possible to, alors it's in French, but maybe it's in English very soon. Look at the left, please. It's possible to create a grid. It's possible to have a land use process with a union and merge with this grid. It's possible to process an hydrographic network. And of course, it's process to the generation of XML file for the simulation for the simulation platform. Create a grid. It's possible to have all possible grids, but very often we take an asymmetric grid. Union and merge, it's very simple. It's just only the union and the merge of the grid with the land use. Hydrographic network process is we have a polygon, and at the end, it's necessary to have only a center line. And of course, at the end, we generate the XML file. So the same, but in details from a point with X and Y. It's possible to have an asymmetric grid. It's possible to join aggregation of the with classes and possible to mix. It's possible to mix land use. It's very interesting because sometimes we have agriculture parcels, but we have holes, and it's possible to put land use in holes with another land use. You understand? It's very important. Hydrographic network is close classic triangulation, segmentation, calculation of slope, and the adjacent administrative entities with the communities, and of course the creation of the XML for the platform for SYMBIOSE. And we have all the specificities of this processor in that slide. And now spatial and time calculation can begin within the SYMBIOSE platform. So we have the data first, the preparation, we saw the geoprocessor, and now in SYMBIOSE. The result is a net CDF or a geo database, but it's possible to map. Because decision maker very often wants a map. They would like a map. And if the map is in 3D, and if the map is in with animation, they are very happy. Alors, I have an animation, but it's not possible because we transform the file in PDF. And with the animation, it's possible here to, alors, sorry, the conclusion, the plugin created with QGis, taking into account the reality of the landscape. It's possible to import a grid, of course, or to create, and the land use is modeling with the local database or satellite scene. And it's possible, like I said, to join and mix every other layer. For each step can be performed independently for other applications. The output is general an animation, and the aim, of course, is to spread SYMBIOSE with QGIS. An animation, for example, here you have the total on the left. You have the total dose, and you have the ventilation of the total dose with cloud The first is the cloud, the second is the deposit, the third is the ingestion, and the fourth is the inhalation. Of course, there is no animation because we are in PDF, but it's ingestion the most important one. So you see, with the time, we see the chart, and it's possible at the end to see the result. It's very important because when we stop the animation, we stop also the geodatabase, and it's possible for the decision maker to have the population concern at this time and at this point. The second animation, it was for Fukushima. It was leafy vegetable. It was iodine concentration in leafy vegetable, and the calculation were made only where the product is. So only in the green area of on the left, not on the white. And why? Because it's forest. So it's not interesting to calculate the incidence of iodine in forest because we would like to have in leafy vegetables. And it's important because CPU is less is CPU is very the speed of CPU is speeder, enfin, vite, plus vite, more non speeder. Okay, I think it's the last. Yes, I think it's the last. The last slide. We have a lot of animation in my presentation. I'm sorry. There is a lot of joke. We don't see it. The last one we see it, and it's not. It's a reality because I. It's not a joke. I have the problem 1 year, 20 years ago, and it was this one. In order to start a software, somebody don't know where is any key to start, and nobody don't know where is this any key. Yes. I think it's my last slide, and the next year I was in retirement. Probably I will have at the school because I give some formation for animation in space and time.
So it might not be your last workshop, you're saying. So you might come with the school later. That's good. That's good.
Okay, thanks to you.